Okay, this is Algebra 1, Lesson 2.1. So with these video lessons, I'm always going to ask you guys to please do the warm-up before I just do it. So pause the video or do it before the video and then check your answers when I do them in the video, okay? So with this first one, we have negative 2/3 plus 4 1/3, okay? So what I'm going to do is I'm going to convert this to a mixed number, so negative 2/3 plus 13/3. And so then on top, I'm going to have a 13 minus 2, which is 11/3. And remember what I said, you can leave your answer like that. You don't have to turn it into a proper fraction. And I should have said this is not a mixed, this is an improper fraction. This is not a mixed number, or this is a mixed number. Okay, so negative 0.51 plus negative 2/9. So we have the same sign here. So we're going to combine these and then put the negative sign on top. So after I combine them, I'm going to get 0.08, but it has to be a negative 0.8. Sometimes on these videos I say things and write different things, and I'll try to correct myself. But if you guys catch something, just ask me the next day in class, okay? All right, so we're going to give the opposite of each number, and all the opposite means is it's just either the negative or the positive. So if I have a positive 8, the opposite is a negative 8. This is not the reciprocal. Please don't mix the opposite up with the reciprocal. If I have a negative 2/3, the opposite is just a positive 2/3, okay? And then lastly, evaluate the expression when A is 3 and B is negative 2. So we're going to plug 3 in for A, and when I plug that in, I get 8. I'm going to plug negative 2 into B, and notice that I have to keep that original negative number. So now I have a 12 minus a minus 2, which becomes 12 plus 2, so my answer is 14. So be careful with that, okay? All right, so we're going to look at solving one-step equations today using one variable, and we're just going to use addition and subtraction. So you'll hear the words equation and solution to the equation. An equation is just a mathematical expression or a mathematical statement that has two expressions. Basically, you're looking for an equal sign, okay? If it doesn't have an equal sign, it's not an equation. A solution to the equation is just a value of the variable, which you usually see as like x equals. So to find our solutions, what we have to do is called isolating the variable, meaning we want the variable to be all by itself on one side and everything else on the other side of the equation. So in order to isolate a variable, we use inverse operations, which means to undo an operation. An equation is like a balanced scale. To keep the balance, you have to do the same thing to both sides of the equation. So if in the equation there's an addition sign and I want to get rid of something, the inverse operation would be to use subtraction. Just like if in the original equation there's subtraction, the inverse operation I'm going to do is addition. So whatever the operation you see in the equation, to get rid of it, you're going to use the opposite or the inverse. So we're going to solve this equation and then we're going to check our answer. So we have y minus 8 equals 24. Since 8 is subtracted on this side, in order to get rid of it, I'm going to have to add it to both sides, okay? So I'm going to fill that in. I'm going to have to add 8 to this side. And if I do it to one side, I have to do it to the other. So that allows me to cancel those out, and I get y equals 32. Now I'm going to check that answer by substituting 32 in for y. So 32 minus 8 is 24, so that was the correct answer. All right, so if you want to try this one before I do it, you can. If not, follow along. So we have this minus 7/16 on this side. So in order to get rid of a negative something on one side, that means we have to add it. So if I want to get rid of it, I'm going to add 7/16. And if I do it to that side, I have to do it to this side. So this cancels. Now, if you want to write this over to the side so it looks a little nicer, when you add Remember, as long as you have a common denominator, that's okay. So we're going to get 12 over 16, okay? So z is on that side, equals 12 over 16. I just wrote it the other way. I don't know why I like to write my variables on the left side. And if you want, you could simplify this. 4 goes into 12 3 times, and it goes into 16 4 times. So 3/4 is our answer, but we need to check that answer. I'm going to have you plug in the answer the original way we had it, so then we don't have to change our denominator and everything. So now, when I subtract 12 minus 7, I get 5 over 16. So that is the correct answer. But again, I want to remind you, you should give your answer in the most simplified form, okay? It can be simplified. All right, so now we are going to move on. So we're going to solve these two equations and then check. So if I want to get rid of 17, I do the opposite. I subtract 17. So m is equal to 16. So to check my answer, I'm going to plug 16 back into 17, or back into m, and 16 plus 17 does equal 33. Make sure you guys aren't just like plugging it in and then saying, oh yeah, it equals it. You should check that it actually equals it, because that will help you know if you have the right answer, and then you'll know if you ever get something wrong. Okay, we see the t is on this side, so that means I want to get rid of everything next to it. So I want to get rid of that 1.8, so I want to subtract 1.8. So 4.2 minus 1.8 comes out to 2.4, and that is what t should be equal to. So I'm going to check my answer by plugging 2.4 back in to t. So does 2.4 and 1.8 equal 4.2? Yes, it does. So that was our correct answer. Remember that subtracting is the same thing as adding the opposite. Oops, maybe I could spell, that'd help you out. When solving equations, you will sometimes find it easier to add an opposite to both sides instead of subtracting. So just keep that in mind. Okay, so here's an example. So I have a negative 5/11 next to the p. They're on the same side. So in order to get rid of it, that means that I need to add 5/11. And if I do it to one side, I have to do it to the other. So those cancel, so I have just the p left on this side. So now I have a negative 2/11 and a positive 5/11. Well, a 5/11 and a negative 2/11 is going to equal 3/11. Okay? And again, we should check our answer. So does this come out to negative 2/11? Yes, we're good to go. All right, word problem. So over 20 years, the population of a town has decreased by 275 people when it's now at a population of 850. We want to write and solve an equation that tells us the original population, meaning before it decreased by 275 people. So we have this nice little word set up here. The original population minus the decrease, which we know the decrease would be equal to or is what now the current population is. So we don't know the original population. So I'm going to use a variable. You can use x, you can use something else. The minus tells us we need a minus sign. The decrease in population we know is 275 equals the current population, which we are told is 850. So now to solve this equation, I'm going to add 275 to both sides, and x is equal to 1,125 people. Okay, so this is our equation. This is our answer. Okay? Just a reminder, okay, these are the two properties that we've been using to solve these equations. The addition property says that basically if I want to get rid of something, I can add it, and if I add it to one side, I have to add it to the other, okay, in order for it to be true. Just like with subtraction, if I subtract something from one side of an equation, that's okay as long as I do it to both sides. So just a reminder, when we're solving equations, we need to do things on both sides, and we are done with your notes.